Okay, now it's not required that you use a database with strict two-phase locking and have serializable schedules. It is possible for you to configure your database and configure a particular session to use different levels of isolation. Serializable is one we've been talking about, but these are all settings. All these things in red are settings that you can set for a given database session or for to configure the database. If you want better performance and you don't care about isolation, you don't care about ACID properties, you usually have ways that you can configure the database to allow more lax concurrency control. So one of those is called read committed. So you can set your database to be read committed, in which case it'll allow dirty reads and unrepeatable reads and what we call phantoms. I'll get into phantoms a little while later. What this means, you can set your database up so that you don't have isolation. You know, you have your transaction, you read and write some things over your transaction, I have mine. I will actually see the results from yours before your transaction commits. You might wonder why, after all this talk I just said about transactions and how wonderful they are, why would you ever do that? Well, there's some cases where maybe it's a read-only system and you really don't need transactions. I think it's a performance benefit by setting your system to be read uncommitted. There's other levels too. One's called read committed, and these are I believe are SQL standards. Not all database vendors implement them, but this is part of the standard. You can have read committed. That is, you allow unrepeatable reads and phantoms. Then we can have repeatable read, meaning that you allow phantoms. A phantom means that while you're in the middle of your transaction, somebody else adds a row to a table so that when you read the table once and then you read it again, you'll notice that maybe something has changed in the table, like a row has been added. They're not allowed to update rows concurrently, but they are allowed to do such things as add or delete a row while you're in the middle of your transaction. And you know, that seems like a pain, but I guess there are certain cases, special cases, I'm not going to go into them, but there's certain special cases where people would like these things. The default, though, is usually serializable. That is, use two-phase locking or something equivalent to it to make sure that the transactions are isolated from one another. And here's a definition of phantom right here, sorry. It's a record that appears or disappears during a transaction. So again, you have a transaction that's going along and reading and doing aggregates and other things like that, and you know, maybe doing updates. And then another transaction adds a row to that table or deletes a row from that table. And the phantom means that now my first transaction is allowed to see that for some reason. Again, probably not a smart thing to do, but by setting your database to be repeatable read, it does allow that kind of thing to happen. So here's I talked about read uncommitted. Here's an example of read uncommitted. It is, you begin your transaction, update A and set A equals 3, A.3, where A.B equals 5, and then go ahead and do that query and you get an answer here. Because now I've set all these to the case where this is true, I've set them all to value 3, so I get the correct answer. Now my transaction 2 comes along and it says wherever A.B is 5, I can read that. Now the question is, if it's read uncommitted, that will allow transaction 2 will allow to see the new answer of 3, even before transaction 1 commits. That's read uncommitted. And here's how the database does these internally. So usually if the database wants to have read uncommitted, they just don't use locks. They want read committed, they obtain write locks, X locks, but they release those locks immediately, okay? Now, if they want repeatable read, what they do is they lock individual objects like table rows, but they don't lock the entire table. And think about it, if I'm gonna read a row from a table, That's great. I can get an S lock for that row in the table. Should I get an S lock for the table itself? Probably should if I don't want phantoms, because if I don't get a lock for the table itself, then someone else can come along and add a row to my table or delete a row from my table, because I don't have a lock on the table. All I have is a lock on the row. And so repeatable read means I only get a lock on my row, my individual object, but I don't get one on the table. Okay, that's repeatable read. And then with serializable, I lock sets of objects. So I lock the row, I also lock the table as well. And that prevents from occurring. Might also, I lock the table, I lock pages of the table, I lock index ranges even. So you got to worry about indexes. If I update something in the table, then what does that mean for the index? Okay, so in review, we need concurrency if we want to have good performance. But if we want to have correctness, then we need to do additional things. Correctness demands locking, demands transactions. Concurrence conflicts with correctness. Okay, these two are at odds with one another. And there's multiple situations to consider. One is two users accessing different data or two users accessing the same data. Both of those need to be managed. They both need to be, this needs to be, have good performance, and this one needs correctness. Okay, the next key thing I want you to remember is a serial schedule. Serial schedule is an in-order execution of queries and transactions. It's an actual execution of one transaction at a time. A serializable schedule is indistinguishable from some serial schedule. It's interleaved, it's more efficient than making each transaction go one at a time. But the results, the end results, are the same as if the transactions had gone one at a time in some order. We don't care which order, but in some order they went one at a time. Two-phase locking is the way that the database implements serializable transactions. It's a mechanism for guaranteeing a serializable schedule. As a transaction goes along, as it does reads, grabs S locks. As it does writes, it grabs X locks. And there's rules for which locks you can get depending on whether the locks are already held by another transaction on a particular object, a particular row of a table. You hold the locks all the way to the end at the commit or the rollback of the transaction. And then for special cases, there are weakened isolation levels that you can configure if you really know what you're doing and you really want to. And then finally, remember that there are S locks, read locks, and X locks, write locks. You can have multiple S locks on some data at the same time, but only one X lock, and you cannot get an X lock if somebody else holds an S lock at the same time. Two-phase locking is the algorithm that the database uses to enforce isolation. And if you do all that, then you can have serializable schedules. You can have concurrency, better use of resources, better performance, while still being predictable, still being serializable, and guaranteeing correctness of your transactions.